3 years ago, I set out to do my PhD at UTS within the climate change cluster, looking at how we can use waste as a resource to reduce greenhouse gas emissions. My research focuses on uniting two high-emitting industries to develop a network to reduce emissions using microalgae, specifically to capture carbon dioxide and with the aim to potentially reduce methane gas. To put that all simply, my PhD is the intersection between cows and beer. So when we make beer, we combine some grain, yeast, and with the power of fermentation, we get three main components. 1, a liquid, being our beer. 2, a gas, being carbon dioxide. And 3, a solid waste, known as brewer's spent grain. Now in Australia, we know what to do with our beer, but we have a harder time figuring out what to do with the two major forms of waste produced when we make it. And this is where my research comes in. So C3 has an existing partnership with Young Henry's Brewery down in Newtown, and we've set up bioreactors on the brewery floor that are filled with microalgae. The great thing is this microalgae has the ability to capture the carbon dioxide made during the beer making process. We can then collect this algae biomass from these bioreactors, and it's full of nutrients that are desirable for livestock feed. Ruminants, specifically cattle and sheep, naturally produce enteric methane when they ferment feed. This is considered a major greenhouse gas within the livestock industry. Microalgae, when included in ruminant feed, has been shown to have the potential to reduce the production of this enteric methane. My research then looks at how we can mix this algae biomass with the second form of waste, the brewer's spent grain, to create a feed that could potentially reduce methane emissions from cattle and sheep. With over 700,000 microalgae species known to exist, I set out to look at which one was most effective at reducing methane production, as well as its effects on ruminant performance. In the lab, I've tested 26 species of microalgae using techniques that mimic the internal environment of the cow's rumen. I then use analytical chemistry to determine the effect of microalgae on rumen fermentation and methane production. From our lab results, I then selected 2 different types of microalgae species and combined it with brewer's spent grain to develop a lamb performance pellet. This performance trial was to take a deep dive into the effects of microalgae on lamb performance parameters, carcass characteristics, and meat quality. If a feed additive doesn't support healthy, productive animals and high quality meat production, it's not going to work for farmers and it's not going to work for us, the consumer who enjoys this nutritious form of protein. A truly sustainable solution needs to be comprehensive, one that benefits the whole supply chain. So in my research, that's from the brewery to the paddock, then the plate.